Welcome to Ask and Learn.
This question we have to balance the redox reaction. So we start with taking the two halves of the reaction. So part A, we start with SO3 negative, 2 negative goes to SO4, 2 negative. So we start by balancing the oxygen atoms, and on left hand side we have 3, on right hand side we have 4. So we add one water molecule here, and then we have to balance the hydrogen atoms, so we add 2H positive here, and now we have to balance the number of electrons, so we will have to add 2 electrons here since this gets cancelled to give a 0 charge, and we have 2 negative here. Okay, now in the next one, next equation, next half equation, we have Cl2, that is chlorine, goes to Cl negative. So in this one, first we have to balance the chlorine atoms, so 2 Cl negative, and then we will balance the equation by adding 2 electrons on this side. So this equation is our oxidation reaction because we end up losing electrons, and this equation is a reduction reaction since we end up gaining electrons. Okay, and now we add these 2 electrons, so this gets cancelled and we end up having H2O plus SO3 2 negative plus Cl2 goes to SO4 2 negative plus 2 Cl negative plus 2H positive, and now we have to balance the H positive, or we have to include hydroxide ions since this is a basic solution. So we end up having 2 OH negative this side and 2 OH negative this side to balance the protons. So this gives us 2 water molecules, and it goes to the and the one which is on the left hand side goes to the right hand side to give us 1 water molecule. So the overall equation that we end up with is SO3 2 negative plus Cl2 plus 2OH negative goes to SO4 2 negative plus 2 Cl negative plus water. Okay, and now SO3 2 negative goes from the sulfur goes from oxidation state +4 to +6, which means the oxidation state is increasing. That means that is the reducing agent, whereas for chlorine the oxidation state goes from 0 to -1. Okay, and the which is a decrease in the oxidation state, and we end that end up being the oxidizing agent, which means it's oxidizing sulfur trioxide and itself getting reduced. Okay, so okay, this is Cl2. So yeah, this is part A, and now we go to part B, and again we do the same thing, that is taking two halves of the reaction. So the first half is ferric cyanide with a -3 charge, which goes to FeCN6 with a -4 charge. Okay, and now we have to balance this just using electrons, so we just add 1 electron here and this will become our reduction reaction. And for second one, the rhenium, this goes rhenium to ReO4 negative, right? And then we have to balance the oxygen atoms first, so we will add 4 water molecules on the left hand side and 8H positive on the right hand side to balance the hydrogen atoms as well. And then we have to add electrons. So right hand side has 7 positive charge, whereas left hand side has 0 positive charge, so we end up adding 7 electrons on the right hand side, and this is our oxidation reaction since we end up losing electrons. And now to balance the reaction, or to add the reaction, we multiply the reduction reaction with 7 to cancel out the number of electrons, so this gets balanced, it cancelled out, and we are left with 7FeCN63 negative plus rhenium plus 4 water molecules goes to ReO4 negative plus Fe7FeCN64 negative, and then 8H positive, right? And now since this was also in the basic solution, we have to add OH negative ions. So to balance the protons, we have to add hydroxide ions, and then we have to add hydroxide ions on the left hand side as well. Now this in total will give us 8 water molecules, so our equation will be and then 8 minus 4, which is 4 water molecules. So this is our balanced equation. Now if you see, iron in FeCN6 3 negative goes from plus 3 to plus 2 oxidation state, and therefore FeCN6 negative will be our oxidizing agent since it experiences a decrease in oxidation state. And rhenium goes from 0 to plus 7 oxidation state, which is an increase in oxidation state, hence that is our reducing agent, which means it experiences an increase in oxidation state, or it reduces FeCN6 3 negative to form to itself get oxidized. So yeah, that's our part B. And now we go to part C. So again we have to divide the equation into two halves. So first we will solve MnO4 negative going to Mn2 positive. Okay, so in this one we have to add water molecules first in order to balance our oxygen atom. So we will add 4 water molecules, and now to balance hydrogen atom we will add 8 H positive here. And now we have to add the charge or the number of electrons. So on the left hand side we have 7 positive, on right hand side we have 2 positive, so we have to add 5 electrons here, and this becomes our reduction reaction since we end up gaining electrons in this one. And now for the second half we have HCOOH, which is formic acid, giving us CO2. So oxygen atoms are already balanced, we just have to balance hydrogen atoms and electrons. So it's 2H positive this side, and then we have to add electrons to balance it. So this is our oxidation reaction. Okay, and now we have to add the two equations. So we have to cancel out the electrons, so we will multiply first equation with 2 and multiply second equation with 5. So this gets cancelled, and we end up with 2 MnO4 negative plus 5 HCOOH, that is formic acid, and then 8 to 16 H positive, 5 2 and 10 H positive, 16 minus 10 is 6, so 6 H positive, and then 2 Mn2 positive plus 5 CO2, and then we have 8 water molecules here, and then there is no water molecule in the second equation, so we will just end up having this. Since this is in the acidic medium, we don't have to add any extra hydroxide ions, so this is balanced chemical equation now. And for manganese, manganese in MnO4 negative goes from plus 7 to plus 2 oxidation state, which is decrease in oxidation state, and hence this is the oxidizing agent, which means it reducing the other molecule by itself getting oxidized. It's oxidizing other by itself getting reduced. Yeah, sorry about that. And carbon in formic acid goes from plus 2 to plus 4, therefore it's getting increase, and this is our reducing agent, which means it reducing MnO4 to negative by itself getting oxidized. And yeah, hope that